At the core of the Roman Empire was their engineering prowess, and most notable of all their infrastructure advances was the Roman arch. The arch bridge and arch structures allowed the Romans to construct buildings with a far greater ratio of wall openings to height than had ever been possible before. The evidence of such architecture is found not only in the Roman Coliseum, but also the labyrinth of arched catacombs that lie beneath the historic city of Rome. It was a technology that had never been seen before, one that allowed boats to pass under walkways and roads, and one that enabled the Romans' famous series of raised aqueducts. So, why was the arched bridge so crucial to the Roman Empire, and what structural properties of the arch have enabled Roman architecture to survive relatively intact, even in modern times? An arch bridge was and is so revolutionary to structural design because the elements of which function almost entirely in compression. Due to the distribution of both dead and live loads on arches, stresses are always translated into compression, allowing for materials such as rock or unreinforced concrete to be used effectively. If you know anything about concrete and rock's material strengths, you likely know that neither function practically in tension loading. Nowadays, concrete beams are reinforced with rebar to allow for tension loading, but the Romans didn't have that capability. As an arch's radius of curvature increases, it begins to behave slightly more like a beam. Therefore, low compression forces or tension forces begin to appear on the underside of the arch. The Pantheon, still the biggest unreinforced concrete dome structure in existence, is estimated to have been the largest dome structure the Romans could have built without collapse. Examining how much load an arched bridge can hold is a little tricky. Since all of the components of an arch function in compression loading, the maximum loading values of any given arch is essentially equivalent to the shearing point of any material. Granite, for example, would be a far better arch construction material than sandstone. Even still, the ability for arches to hold load is far beyond any other structural element, even those today. A well-built arch from stone doesn't even need mortar to connect the joints. Rather, the friction forces from compression keep the structure stable. Rather than spend hours determining the maximum load of an arch constructed from a given stone, let's just settle with a maximum loading value of a really big number. For the Romans, and even engineers today, a solid arch structure's yield point is far beyond realistic loads that the structure would ever see. These same principles that made the arch so strong also made them last so long. When a structure created from arches undergoes a series of loads creating low material stresses and strains, fatigue seen in the arch over time is very minimal, if nothing. Since arches' yield points are so far beyond practical loading values, they tend to last until the rock or the structure is weathered, in turn, a very long time. The Romans did use concrete to build many of their structures, like the Coliseum, which is known to be about 10 times weaker than modern concrete. However, while the concrete was weaker, it was far more resistant to weathering than modern concrete due to the abundance of volcanic ash used in its construction. Through this increased weathering capability and the strength of solid arched structures, Roman architecture and buildings are still around today in nearly all of their original beauty.